Okay, so when we want to start phenytoin, we're going to give a loading dose or a mini load if we need to go, if we already have drug on board and we need to increase the concentration, we might not have to give a full load, but a mini load. There's a couple different ways to deal with this. You can give a population average of 15 to 20 milligrams per kilogram times total body weight, or use our standard loading dose equation, which is volume times your target where you're shooting for plus any drug that's or minus any drug that's on board over your bioavailability times salt form. If you're giving it as a sodium phenytoin salt, you're going to have to use your salt conversion of 0.92. If you're giving an IV, obviously your bioavailability will be 1, but your bioavailability will be less than 1, possibly if you're giving it by another route. Note that larger PO doses, so sometimes these loading doses are, 1,000 milligrams or something. You should divide these because of stomach upset. So you divide these over 3 hours, probably over 3 doses over a 24 or 12-hour period, but divide them up over that 24 hours so that you don't make your patient sick on top of it. All right, we already said that, didn't we? All right, whoops. I don't know why it says the same thing there, but it does. All right. Um, Remember, the total body clearance in this case is totally cleared by the liver. It's low extraction, therefore clearance is dependent upon enzyme activity and binding, and it's cleared mostly by the 2C19 system. And intrinsic clearance, as you know, is Vmax, or the number of enzymes available, divided by Km, which is the concentration where half of those enzymes are being used, plus the concentration. So remember, in most cases, the concentrations we see are much less than the Km, and the concentration falls out of this equation. But so your intrinsic clearance is independent of concentration. That's when you have a linear drug. But in this case, the concentration stays in there because a normal Km, an average Km is about 4 milligrams per liter. And remember, we're going to be in the, 10 to 20. And even if you think about free concentrations are 1 to 2, and that's still very close to 4. So as the concentration increases, you're going to see a decrease in the enzyme activity. So your intrinsic clearance is going to go down as your clearance increases, and since that's a determinant of clearance, that means your clearance is going to decrease with increasing concentration. So how do we start an initial maintenance dose? Well, you can just start with what the PDR says, which is 5 milligrams per kilogram per day, and that's probably what most people do. But only about a third of patients will actually be in the therapeutic range with that maintenance dose. You can try an individualized approach, which is using our good old jelly equation here, which is CSS average um, equals drug in over drug out. You also have to put that salt form in there. Don't forget that. Um, we know what we're shooting for. We know a bioavailability, at least a good guess, but what do we use for clearance here? Good question, because we're solving for dose rate, aren't we? So how do we determine clearance if it's changing with concentration all the time? That's pretty tricky. All right. So that's really the crux of the problem. So we'll talk about that more in just a minute.